Thanks for getting to part 2 of our radon rough-in discussion. In this second part, I'm going to go into much finer detail. We're going to drill down, so to speak, further into the content of the standards that are typically used for doing radon rough-in. And so let's begin. The standard that's used is given here. It is the ANSI AARST standard, and the acronym for it is RRNC-2020, and it stands for Radon Rough-in in New Construction. And you can see here a little bit of a description of it. The standard is not particularly large. I have it right here in front of me, and it's about 15 or so pages, maybe a little bit more than that. And it's well constructed and broken down into what I'll call sections. And I'll describe what those sections are, because the entire document is useful, but there are 2 sections in particular that you will need to pay attention to. You can read it for free by going to this website here, or you can go to this website here and you can read it for free. If you want to buy it, of course, and you certainly can. Now, the breakdown is this, and you can see I've got the sections listed here. I really like this document. It's very well written. Section 200 has the definitions of the terms that are used. That is tremendously helpful. Section 300 talks about the components. 402 and 403 are probably the biggest issues for you, the biggest sections for you. 402 talks about submembrane issues, and really a membrane in this document refers to the vapor barrier, the plastic that you often put down above the ground before you pour the slab, or however else you're going to do that. And then section 403 is if you're pouring a concrete slab down, then section 403 tells you what additional features you need to put into place when you're using poured concrete. Section 402 tells you the features you need to put in if you're not using a poured concrete slab. And then how do you seal the vapor barrier into its place, the type of caulking, etc. That's all given in section 404. Piping issues, as you'll see, it will talk about the types of piping that you can use or that you should use. Section 6 talks about exhaust issues. We're going to be taking the radon gas, we're going to be exhausting it to outside before it has a chance to get into the building. And so where do you exhaust it exactly? And that's dealt with in section 600. And if a fan is used at a later date, we're talking about a rough-in now, and a rough-in does not include the exhaust fan. But if later on a radon concentration is found to be above the action level, then the occupant may well want an exhaust fan installed. And section 700 talks about the exhaust fan issues. And amazingly enough, even though the rough-in does not include a fan, the rough-in has to leave enough space for the fan to be installed and in a proper location. We'll talk about that. But I like this because really section 402 and section 403 are the ones that we will focus most of our attention on. Now, there's no way in a 30-minute video that we can cover all the different aspects of a radon rough-in system, but we will cover a lot of it, and you will have a good handle on it when you finish this 30-minute video. Let me point out that any design can be built with a radon rough-in of radon control components. Now, you see here, if you're a slab on grade, if you're in a crawl space, or if you have a basement, all of these are discussed and dealt with in great detail in these standards. And the one thing I would like you to keep in the back of your head during this video is, I say the one thing, it's 2 things. The first thing is the goal here is to make the home that you're building resistant to radon entry and ready to install a fan if a fan's going to be needed later. In some cases, this passive system that we're going to be discussing may be enough to keep the radon concentration below the action level, but in many cases it may not be enough, in which case a fan will be installed later, and that is incredibly successful if a fan is required to get the radon concentration down below 4. And the excuse me, the other thing I'd like you to remember is that radon is a soil gas. It comes from the ground, as we discussed in the first video. It comes from the ground, and because of the soil gas pressure being slightly higher than the atmospheric pressure or the interior building pressure, at least at the low levels, it drives the soil gas into the building. I want you to remember those two things, because those two things are essential to our understanding how these rough-in systems are going to work. And once you understand what the goal is and how they work in general, it all makes sense. We're going to look at two cases, and that refers to those two sections that I talked about a moment ago. We're going to look at cases where concrete floor is used, and we'll call that a subslab install, as you see here. And those cases where there's no concrete floor installed. You might have a crawl space with no concrete, and you may have other conditions where there is no concrete floor installed, in which case we will call that a submembrane or a sub-vapor barrier installed. You, the builder, have a very important role to play in preparing the ground. Now, there's not a lot for you to do. In many cases, you'll have already done 70% of it. You only have to do a little bit more to install the radon rough-in components. And frankly, in most cases, I think that will be the issue. In all cases, you shall construct, as it says here, the foundation areas so as to create, as I'm just reading, create a sealed soil gas collection plenum. In this first bullet, what we're talking about is, remember, it's a soil gas coming up. What we're going to do is we're going to capture it before it has a chance to get into the building, and we're going to give it an opportunity to evacuate itself out into the atmosphere before it has a chance to get into the building. And so what's called the plenum here is simply the volume within which we're going to capture this radon and start its trip through its exhaust pipe. If you're using any groundwater control systems, the second bullet, inside the foundation areas, for example, if you're putting in a French drain or something along that order, you want to make sure that the water that's collected in the French drain, or the water tables rise up to the French drain, does not interfere with the soil gas collection plenum. As we go along, this will make a great deal of sense to you. Next, let's talk about the components themselves and some what I consider almost obvious items of interest. And you'll notice here in this first bullet, it says you should complete these things prior to finishing off the house in general. Now, and that should be pretty obvious to you. If you're going to run an exhaust pipe up through an interior wall of the house, you're going to do that before you put the sheetrock in, obviously. And so some of these things are going to seem pretty transparent to you, but it doesn't hurt to bring it to the front of your mind for just a second. So the items that we're looking at that will be part of these rough-in components, first is the plenum, and that's a general term to cover the entire area or volume that will allow us to capture the radon and direct it to the exhaust so that it has the opportunity to go outside. We have a gas permeable layer, and the first example I'm going to look at is certainly one of the more common constructs in Pennsylvania for the slab, and that is a gravel base with the slab poured on top of that, and usually with a vapor barrier in between the gravel and the concrete slab. That's going to be my first example. So you have the gas permeable layer, which in this case will be the gravel in this example. We have what's termed the soil gas retarder, And that's just the vapor barrier. Now, they're called soil gas retarders. Sometimes they're called a membrane within the standards. But fundamentally, for us, it's just the plastic sheet you're going to be putting down for the vapor barrier. And there are specifics to it, but specifics such that I believe you're probably already using that kind of plastic. You'll have the soil gas collector, and that in this example would be the perforated pipe. You'll see all this in just a moment. And then the type of piping for the exhaust, what the suction point should look like. Where does the discharge point have to be? Obviously, you want it discharging. It's going to turn out to be a foot above the roof where the exhaust pipe penetrates the roof. And you're going to have wiring and probably a switch for the electrical components, which will make the fan installation, if needed, easy. So we're going to take a look at all of these components as we look at our first example rather, of a radon sub-slab system. So this will be a sub-slab with a gravel aggregate. And you see here in the drawing, there's a gravel base, and I indicate that just with the words gravel base. So all of this is gravel. And the specifics of the gravel are given in the standards. And you can see I make a note here. It has to be at least 4 inches in depth, and I'll bet you're doing that already. And it must have 35% voids. And the standards tell you the size of stones that are used for that to accomplish 35% voids. And I'll bet you're doing that already. So you get the gravel base that you're going to have in here. Then you're going to have, I'm going to skip over the perforated pipe for the moment and go to the vapor barrier. Normally, I think in most construction, you'd have the gravel base, you'll have the vapor barrier, and then you'd have the poured concrete on top of that. And so really what you're going to add to your construction techniques using this rough-in is you're going to have this plastic tee that I'm pointing at here, and you're going to have some perforated pipe on either side. Now, let's talk about these things. The perforated pipe has to have at least 5 feet of length on each side of the plastic tee, as you see. And the plastic pipe, the perforated pipe, should be seated into the gravel. So put it down into the gravel somewhat. And the perforations are even given that you must have at least 1 square inch of perforation per foot length of the perforated pipe. And I'm quite sure that's all satisfied by what you're already using. Anyway, it's easy enough to check. So you have the vapor barrier, and then you have the plastic pipe that goes up here through the roof. So I think if you look at this, it doesn't look like we're adding a lot. We're adding the T and the 5 feet of perforated pipe on either side of the T, and the exhaust pipe, and that's it. And the rest of it, there are 1 or 2 additional features here that I'll point out to you as we go along. But fundamentally, that's all additionally that you would need to do if you're using a gravel aggregate, the vapor barrier, and the concrete slab. So not particularly difficult and not particularly expensive either. Some of the details that are given in the standards, and I point this out here to you not so that you remember it from this slide, but rather so you'll see what kinds of details are given in the standards, that the standards have in fact worked out the best way to do these things. So, well, let's talk about the soil gas retarder on this slide, and that's just a vapor barrier. That's that plastic sheet you're putting down. And it should be at least 6 mils in thickness or cross-laminated with 3 mils of thickness. It should completely cover the area under the slab. You should have the seams overlapping by at least 6 inches. And where the seams are, you can caulk it with this kind of caulking or tape to tape the seams together. Tape that's recommended by the manufacturer. And that is there to prevent the plastic from moving around while you're pouring the concrete slab. If there are penetrations, and there will be penetrations through the plastic, and those are how do you solve those penetration? How do you seal them after you've cut the hole in for the pipes that are coming up? And how you seal them up is given in the standards, and it involves tape, caulking compound, and an extra sheet of plastic, typically surrounding the penetration. Not hard to do. Same thing with repairs. If there's a rip in the plastic, how do you repair that? Same thing, it's either tape, caulking, and an additional piece of plastic on top of that. Really very easy things to accomplish. The soil gas retarder should run 4 inches up the wall. Now, I've put this picture in here, which is unfortunately, it's a crawl space, as you can no doubt tell. And here's the pipe, the exhaust pipe that's coming up. It's not going straight out. This is a house that's been rehabbed. And you'll notice that the pipe comes up and it makes a turn to the right and then goes up again. We'd like to avoid that if that's at all possible when you're doing a new construction. In a new construction, you should be able to avoid that. But the reason I put the picture here is because you can see that the plastic is run up the wall. Now here it's run up what appears to me to be more than 4 inches. And so that's just a picture to show you what it's going to look like when you do it. And then where the floor meets the foundation, you need to seal that as well. You can't afford to leave any place for the radon gas to come up and come through the cracks and spaces of the foundation. So that's got to be as close to airtight as you can make it. And so that's the reason for these remarks. And I should like to point out that the concrete itself is not impervious to radon. There's a thing called the diffusion coefficient. It tells you effectively how easy it is for gases to penetrate different materials. And there's a diffusion coefficient for radon in air. How easy is it for the radon to diffuse through the air? And then there's a diffusion coefficient for radon through concrete. That is, while the concrete looks really solid, there's a lot of space in there for the radon to actually percolate right through the concrete, through the empty spaces it's in the concrete. Now, it's much more difficult for it to percolate through concrete than it is obviously through air. So the concrete does produce a pretty good barrier. However, the vapor barrier is between 100 and 1,000 times better than the concrete in preventing the gas from getting up into the building. And so the purpose of the vapor barrier will be, of course, to capture the radon, and hopefully we'll get it driven out through the exhaust before it has a chance to get into the house. Next, I want to discuss the case where you have a poured concrete slab, but instead of being on some gravel, a good gravel base, you're pouring it directly on the dirt or sand. And so I've titled this here as you can see, subslab with sand or small aggregate base. And in this case, it's going to be similar to the case with gravel, except for 1 or 2 minor adjustments. And in fact, we use the same picture as we did for the case with gravel. And you'll notice I simply identify the base as sand or small aggregate base, so that's this stuff here. And then we have a T-fitting with a perforated pipe here. The T-fitting would be here. And then, of course, the exhaust pipe going up here and through the house. You'll notice there is a vapor barrier as before, same conditions on the vapor barrier, 6 mils, etc. The difference is going to be here, instead of just 5 feet of pipe on either side of the T, of perforated pipe, we're going to have an entire loop that goes along the perimeter of the foundation. A foot to 1.5 feet from the foundation itself, you're going to run this pipe all the way around, making a loop. And that'll be all perforated pipe, and the goal of that pipe, of course, is to collect the radon and deliver it towards the exhaust vent, the vertical pipe that you see right here. Excuse me. The reason we use a lot more pipe in this case, where there's, let's say, sand or dirt under the slab, immediately under the slab, is that the radon doesn't communicate well through the dirt, at least not as well as it does through the gravel, as you'd expect. That is, it doesn't travel as well. So if you had just, let's say, 5 feet of perforated pipe here, it may not, even though the pressure is lower in that pipe than it is in the rest of the soil, it may not do very well in getting the radon to come from, say, 30 feet away over to that pipe. And so we're going to give the radon an opportunity to get into pipe all the way around the perimeter. And that's the fundamental difference. I'm going to talk about that a little bit here. As you can see here, here's the trench. I'm drawing one way you could put a trench, some gravel, and put the pipe, embed the pipe within that gravel. This is just one way to do it. The conditions are approximately this, that at least a third of the pipe, roughly, has to be set within the gravel. And the other condition is that the total cross-sectional area included by the pipe cross-sectional area and the cross-sectional area of the trench, the sum of those two has to come out to be at least 50 square inches. Those are really the two conditions. Now, you can make it bigger than that. These are all minima. And so I came up with one idea of how you could do this, and I went through a couple of ideas, but this one, to me, seems to be the easiest to install. And I'm suggesting that one way you can do this is you run a 6-inch deep trench, 8.5 inches wide. And obviously that gives you 50 square inches of collector area, cross-sectional area. And my thinking is, if you dig this trench 6 inches down, put in an inch of gravel, then put the pipe in on top of that, and then cover the pipe sides and top with gravel, then you'll have, and make a whole loop out of it, then you'll have a great collector area. And it'll satisfy the requirement of 50 square inches of collector. Satisfies the case that a third of the pipe is in the gravel. These are all minima. And so here, the whole pipe would be in the gravel. And the trench gravel is supposed to have 35% of void space, as in the other case with gravel. And I make an additional note here that the center line of the pipe is to be 12 to 18 inches from the foundation walls. Now, obviously, you're going to be running this trench. You might come to a place where there's some plumbing coming up through, so you can't run your trench there, so you run the trench around that. Those are permissible things. And again, you can look at the standards and see specifically what they say and work out your own plan of how you're going to do this for all the houses that you're building. And it's very likely, if you're building on sand or dirt, just as if you were building on gravel, you're going to devise one plan that you'll use over and over and over and over again. So you only have to work it out one time. And it's not hard to work out. It's really very easy. It's certainly easy for all of you contractors out there who do this kind of stuff regularly. A few additional features as before. The vapor barrier, if there are any penetrations, you have to make them airtight, or as airtight as you possibly can. And so they suggest you seal them with caulk. If there's a tear, you repair it as you did in the case of the gravel, and you'll see all that in the standards. I'm just going to come down here again. The intersection of the floor and the foundation walls that'll be sealed with caulk. You're to run the vapor barrier up 4 inches. I see my face is a little bit in the way of this, so I'll go to here. You're to run the vapor barrier up 4 inches along the foundation walls, and then seal them at the top, of course. And regardless of whether it's concrete poured foundation or concrete poured walls or block walls, masonry block walls. The vapor barrier goes up the same 4 inches. If you're pouring the floor and the footings all in one shot, so to speak, then the vapor barrier shell, you're going to put that down first, obviously, and you're going to put that completely under the footing as well. And again, there are other ways you could build a trench. You can make it shallower, have the pipe sitting above the trench a little bit. Lots of different ways to do it. I think the way I'm suggesting is simply an easy way to do it. And if I can go back to that picture one time here, and here, I've suggested making it 6 inches deep and 8.5 inches wide. Obviously, that gives you the 50 square inches that you need. But suppose your backhoe is a 1 foot backhoe, so you've got a backhoe that just digs it 1 foot wide. Then make it a foot wide. You can make it bigger. You shouldn't make it smaller, but you can certainly make it bigger. Next, I want to consider crawl spaces. And really, there are 2 choices for crawl space. Either you have a gravel base or you do not have a gravel base. And I want to look at 2 options for those. And you can see from this image here that the crawl space is going to look a lot like what we've been doing. And that is, there's going to be the exhaust pipe going up, of course. There'll be a T, as indicated here, and some perforated pipe that you can put here. And of course, a vapor barrier, or sometimes called, excuse me, the membrane, to trap the gas. And remember, the goal is we want to trap the gas within that plenum. So let's take a close look here. You'll notice the vapor barrier is sealed along the vertical wall. And let's go to the first case, and that is where you have a gravel for a soil gas collector. So I'm going to look at 2 possibilities here. You either have gravel, that's what we're going to say is going to collect the gas, and or you're not going to have gravel, and we'll see what to do with that. If you're going to be using gravel, then it needs to be 4 inches deep, same specifications as the gravel we've discussed before. And it's probably gravel that you're already using. 35% void space, and the additional specifications of the gravel are given in the standards, but pretty much this is what's important. Then you're going to have the T fitting, as you can see, and then you're going to run perforated pipe for a length of at least 5 feet to either side of the T. And you're going to place that pipe within the gravel. And of course, you also have the additional constraint here that, let me just see, 1 square inch of perforation per linear foot of pipe. And we've seen that condition before. And again, the vapor barrier sealed along the vertical wall. And in this particular case, for crawl spaces, the height up along the wall that the vapor barrier needs to go is not specified. So I put it up a few inches and seal it. I put it up probably 4 inches and then seal it. So that's what we do if you have gravel. If you have gravel, you just take the perforated pipe and the T, you put it in the gravel, and you make sure the pipe's at least 5 feet in length, and the vapor barrier, and you're done. Let's take a look at the case where you don't have gravel. Now, if you don't have gravel, what you're going to do is, instead of using the gravel, which you don't have, to collect the gas, you're going to put a pipe, a perforated pipe, to collect the gas. And that's going to be put into a gravel trench, as we've seen before. Not quite as we've seen before, but close. So what we're going to have here is pipe, and you'll see you're going to call the pipe the soil gas collector, and the pipe's got to be 4 inches minimum diameter, and all the pipes we've seen so far are 4-inch diameter pipes. Not less than 10 feet in length. So you have a total length of pipe of at least 10 feet, and really the longer the better. And then you're going to place that pipe in a trench with gravel completely surrounding the pipe by 4 inches on all sides. So that means if the pipe is immersed in the trench and you look from left to right, you've got 4 inches of gravel, a 4-inch diameter pipe, another 4 inches of gravel, so you got a 12-inch wide trench, and you're going to have likewise a 12-inch deep trench, so a 12 by 12 trench. Again, the bigger the better. And again, the vapor barrier. So that too is really pretty easy to do. Now, some of this I've already mentioned. If you're using a pipe soil gas collector, really you're going to put a T in. You're going to have 2 horizontal openings and 1 vertical, so that's a T. Another variation you can do is you can put an entire pipe loop in if you want. And then for the gravel soil gas collector, just to underline this, you got to have 2 horizontal openings and 1 vertical, so that's another T, and a minimum of 5 feet of perforated pipe from each side. Remember the difference between the gravel soil gas collector and the pipe soil gas collector. The big difference is that in the pipe soil gas collector, you have to dig a trench and put gravel in it. Okay? And then you need to fasten all the suction points. All the T's have to be firmly attached in such a way that they won't be moving around as the years go by. And to go on a little bit further, we talk about the vapor barrier, and you'll notice the type of vapor barrier to be used has to meet these requirements, and really you won't have any trouble in meeting these requirements. You probably got that kind of rolls of plastic available. And as we've seen before, the seams will be overlapped by at least 6 inches and then sealed in accordance with a caulk, complying with this ASTM, and I'm sure you have that caulk. Or you can use tape to fasten the seams together. Tape recommended by the vapor barrier manufacturer. And one other little item, but important, is that the vapor barrier needs to be labeled. And I would put the label where the entry into the crawl space is, so that someone walking in can realize, oh, this is important vapor barrier. I should not be ripping this up or tearing it or damaging it in any way. And the size of the characters to be used for the label and what the label needs to say are given again in the standards. It's just a label that you're going to affix to the vapor barrier. And as we've seen with vapor barriers before, repairs and penetrations and how you seal it on the foundation walls are all given in the standards. So again, this isn't difficult to do, and I know I'm repeating myself, but the truth of the matter is, once you've worked out how you're going to do it for yourself, and you're going to use probably the same method in all the houses you're building, then it becomes really easy and relatively inexpensive. Next, I'd like to discuss the part of the rough-in system that is above the plenum, that is from the basement or poured concrete up. And you'll notice I have in this drawing here depicted the exhaust pipe going straight up and out through the roof. And one of the remarks I'd like to make here is that is the ideal situation if you can get the exhaust pipe to go straight up. It would require some planning to identify the precise location, say in the slab, where that pipe, where the T needs to be fixed. But that's the ideal situation. You can't always get that. Sometimes you've got to have a bend or two in order to get it up through the roof line. But in any case, I just make that remark. Also, you'll notice there's a little bit of another vent pipe indicated here, and that would be going to another suction point. I'm going to show you the need for that, on a few occasions. But let me further go on and point out that the problem that we have witnessed a few times is leaving enough space for the fan through the attic. In many cases, it's going to be placed in the attic, and you have to leave enough space. So you see here it says minimum fan space needed is 36 inches high and 21 inches wide. You need that amount of space or more to install the radon exhaust fan. If you don't leave enough space, then you've got the pipe coming up, and you're going to have to make it a 90-degree turn to move to a space where there's room for the fan, and then another 90-degree turn to connect to the fan and go vertically upwards. And so that would induce 2 additional 90-degree turns, which diminishes the effectiveness of the system. So try as best you can to make it as straight up as you can. You'll notice there's also an electrical outlet box. A junction box needs to be placed so that you can hardwire the fan into that box or plug it into the box. And I'll make a few more comments about that in another few slides. Next, I would like to make a couple of remarks that if you have more than one kind of foundation, as I'm depicting in this drawing here, you'll notice there's a basement, and then there appears to be a crawl space here, and you would presumably put in the correct kind of rough-in over here, and a similar correct kind of rough-in in the crawl space where you see this blue vapor barrier. Depending on what's down here, whether it's gravel or sand, will determine how you install the rough-in down here. But the point I want to make in this slide is that you'll notice there's a vent here, a vent pipe that comes up here. There's a T, in other words, and a vent pipe that comes up here, and it connects into what I'm going to call the main vent for the radon. And if you're using 3-inch exhaust pipes, 3-inch diameter, then the maximum foundation area that you can cover with that is 2,500 square feet. That is, if you're using 3,000, if you're looking at a 3,000 square foot house and you're using a 3-inch exhaust vent, then you're going to need what it says here, an additional rough-in with an independent exhaust point. If you're using a 4-inch exhaust, then you can cover as much as 4,500 square feet of total foundation area. If not, if the foundation area is more than 4,500 square feet, then you're going to need a second independent exhaust point. And I depict that in the next slide here that you can see. And you see here the difference between the last slide and this slide is that this exhaust point doesn't go and connect with what I called the main exhaust line, the main vent pipe. This has its own vent pipe that comes up and penetrates the roof here. It will have its own electrical box for the case where you may need to put in an exhaust fan, or the owner may want an exhaust fan put in later if the radon concentration is still too high. Next, I'd like to cover some odds and ends that you can find toward the end of the standards. And I'm going to start with labels. And I'm going to start with labels because I think labeling is important. It's important that we label the vent pipe, for example, and you can see the image here of it and of the kind of label you can put on. And the reason that's important is that someone doesn't confuse it with a vent pipe for a toilet, for example, or some other venting that might occur in a house. And you'll see here that the words that need to be mentioned is that it needs to be listed as a vent pipe, part of a radon reduction system. You can see that here. And the font and the minimum size of the label is indicated in the standards, so you don't have to figure that out. In fact, you can buy these labels off the net by some appropriate source, and so you don't have to generate them yourself or anything like that. And you'll notice here it says 2 labels on each floor on either side, identifying that this exhaust pipe is part of a radon system. Really, the standard reads 2 labels on each floor or every 10 feet. So really, that's 2 labels on each floor. And you put one on either side of the pipe so that if somebody should look at that pipe at some point, they would have some sense about what it is. Additionally, You have to put one label in a conspicuous place and a second label within 12 inches of the electrical service panel that reads precisely this way. They even tell you what it needs to say, so that's pretty easy. Remember that the plenum, effectively that vapor barrier and everything below it, we'd like it to be airtight if we could possibly manage that. And so we need to consider things like sumps. They'll have a rigid lid, it'll be sealed. We can go through a number of things. Here's an interesting one. If you're using block walls, the block wall, a lot of it will be in contact with the soil. And the radon can come through the soil and through any spaces on the block wall, including the block walls themselves, and get into the cores of the block walls, the void spaces within the blocks. And then they can drift up, and if the top of the block wall is not capped and sealed, then that radon gas can, of course, just get right into the basement. And so it's recommended that the top course of hollow block masonry walls shall be solid masonry units or fully grouted. You know, I use the word recommended. The standards do make it clear that these things are required. Floor drains and condensate drains shall not allow soil gas entry. You can go through this at your leisure. Really, the goal here is we want to make that soil gas plenum such that it captures the radon with the greatest efficiency. Types of pipe, the piping sizes, the wall thicknesses, etc., all given in the standards. That's the wonderful thing about this. You don't have to invent anything. Everything's been done for you. The only thing you need to do is become familiar with how to do it. The discharge point. I wanted to make a couple of remarks on this because remember that the soil gas radon concentrations, they can be in the hundreds and in the thousands. So you're going to be venting this gas up and out through an exhaust pipe, in effect. And it's going to come out of that exhaust pipe with concentrations in the hundreds and thousands typically. So you don't want to have that exhaust pipe coming out right near somebody's window, obviously, because a lot of that radon could easily get blown back in to the building. That typically is called re-entrainment. But you want to avoid that. So a number of requirements here are given. At least 10 feet, this is the exhaust point now, at least 10 feet above grade at the nearest point of discharge, 10 feet away from any windows or other openings in the building. And you can read through this. But fundamentally, the goal is watch out for the re-entrainment. You don't want the exhaust gas that's being spewed out to have an opportunity to get back into the building. And really, that's pretty much what this is saying. Additionally, if you have equipment ear intakes near where the exhaust point of the rough-in system will be, you need to keep it at least 10 feet away or 3 feet above any mechanical air intake. And some examples are given, and there are probably other examples available as well. I want to underline some fan concerns that I made mention to a little bit earlier. And that is that you need at least 36 inches of height to install the fan and 21 inches of width. So, you know, if you bring the exhaust pipe up close to the edge of the roof, and it's a typically slant pitched roof, then the amount of space you're going to have for the fan may not be enough to install the fan. So a little bit of thinking ahead will help resolve that. You can read through some of these other items here. Effectively, make a look at this. Branch circuit conductors shall supply an outlet within 6 feet of the fan. That is, if you're using a junction box or a light fixture, then that needs to be within 6 feet of the fan. The goal is, if someone needs to service the fan, he needs to be able to unplug or disconnect the fan and see that it's been disconnected before he sticks his fan into his hands into the fan. Okay. And so you can look through this and see what's going on, and note that there should be a label where the electrical disconnect is, and the label should say something like radon fan disconnect. One thing that's been brought to our attention is there may be codes that if an electrical appliance is placed in the attic, that a light must be placed there too, in which case you can put a light in the attic with a plug in it so that the fan can simply be plugged into the light fixture, and that can be used as the electrical connector inside. Do not put the attic light on-off switch anywhere but in the attic. So you'd probably put it with a pull chain that comes down close to the floor of the attic, and put it within 6 feet of the proposed fan location. Obviously, you don't want to put it in the living room or in a hallway, for example, where you might have somebody working on the fan and somebody walking down the hallway say, hey, why is that switch off? Turn it on and electrocute the guy working on the fan. So you want that control up in the attic. A picture of the electrical junction box here. You can see it here, and the note installed within 6 feet of the fan location, and means of labeling it is necessary. The post-occupancy test. You should recommend strongly to the homeowner that, listen, after you've lived in there for a few days or a week or two, you should give a radon test to that building. And that would be up to the homeowner, of course, or the occupant of the building. And you can leave a kit with them. You can get a kit from, if you get it from a local laboratory or any laboratory, you can get kits for $10 a piece or less. You don't have to buy them at the hardware stores where you're going to pay $20 or $25. You can get it for much cheaper than that if you're buying, say, 20 or 30 or 40 at a time. You can negotiate usually a pretty good price. And I've seen them for less than $10 when you buy them by the hundreds. The first time, and I've mentioned this before, the first time you do anything new, there is some ramp up time. You got to learn how to do it. You have to read through the standard. And as you're reading through the standards, oh, this doesn't pertain to me. This won't pertain to me. This won't pertain. Oh, this pertains to me. So maybe make a note of that and develop a mechanism for yourself to put in the rough-in systems. This is not hard stuff to do. You can easily do this. And there isn't that much of it ongoing yet. It's starting to build, but I think you want to be on the leading edge if you can. And you can make it an option to the buyer. So listen, this is the design of the house. We can provide you with granite countertops. We can provide you with carpeting of this quality, and we can provide you with a radon rough-in system, and these are all the costs for these different things, et cetera, et cetera. And the nice thing about this is that you can help to save a life. And more than that, you can help to diminish the agony that someone who gets lung cancer goes through. You have a keen opportunity to do something really good at this time. Give the buyer the choice.